Now, variance and a standard deviation of a random variable. Variance and standard deviation. So the definition is this. Suppose x is a random variable with the values x1, x2, etc. xn with the probabilities p1, p2, etc. pn. X is a random variable with the values x1, x2, etc. xn with the probabilities p1, p2, etc. pn. Then the variance of this random variable x, variance of x is defined as sigma I from 1 to n, this xi minus mu whole squared into pi, where mu is the mean of the random variable. So this is the definition. X is a random variable with the values x1, x2, etc. xn with the probabilities p1, p2, p3, etc. pn. Then the variance of the random variable x. So variance of x is defined as sigma I from 1 to n xi minus mu whole squared into pi, where mu is the mean of the random variable. Mean of the random variable. So here consider this. This is xi minus mu whole squared into pi. This xi minus mu is the variation of these x1, x2, etc. xn from this mu. x1 minus mu, x2 minus mu, etc. xn minus mu. And this xi minus mu whole square is the square of the variations. Variations means the deviations, the difference. And the sigma I from 1 to n xi minus mu whole squared into pi gives the expectation of this x minus mu whole square. Mean of the square of the variations. So here we have this x values x1, x2, etc. xn. Then the variations x minus mu is this x1 minus mu, x2 minus mu, etc. xn minus mu. And the squares x minus mu whole square is the squares x1 minus mu, x2 minus mu, x1 minus mu whole square, x2 minus mu whole square, etc. xn minus mu whole square. Then these variations, the square of the variations multiplied with this probabilities, this into this, this into this, etc. this into this, and adding we get this. This x1 minus mu whole squared into p1 plus x2 minus mu into whole squared into p2, etc. xn minus mu whole squared into this pn, the sum, which is the variance, and it is the expectation of x minus mu whole squared, or the mean of the squares of the deviations from mean of the random variable. Okay, so this is the variance. Then the standard deviation is defined as, square root of the variance. That is square root of this, so which is equal to this sigma xi minus mu whole squared pi. This variation is also denoted by the sigma x squared over this expectation of x minus mu whole squared, because This is actually the expectation of the square of the deviations, x minus mu whole square. So it is again denoted by this symbol or the sigma x whole square, or again denoted by this variance of x in this form, var x, variance of x. And square root of this is standard deviation. So this is the variance and the standard deviation of a random variable. So to define this, we need only write up to this. X is a random variable with values x1, x2, etc. xn, and probability is p1, p2, etc. pn. Then the variance is sigma I from 1 to n x minus mu xi minus mu whole square into pi, where mu is the mean of the random variable. That's all. For definition, that much sufficient. But this is actually the mean of the square of the deviations of the observations, the values of the random variable from mean, and that's all. Okay.